Welcome back to another statics video. We're looking at problem 518 from the textbook, which is a frame analysis problem. We've pretty much finished the problem, but I just wanted to kind of tie up some loose ends here. In the previous video, we had analyzed the horizontal member of this frame, and we found that the reaction force was actually pulling down on the left, and we have the externally applied load pulling down on the right. And joint B was pulling this horizontal member up. So what we have to remember is that because it's pulling the horizontal member up, that means it's also pulling the diagonal member down. So if we were to draw our free body diagram of the diagonal member, oops. All right, let's try that again. Got our diagonal member here with joint B at this end and joint A at this end. So again, the joint, the way it was affecting the horizontal member is it's holding it up. It's preventing this 3,000 pound force from pulling the whole thing down. But because the reaction it had on the horizontal member was up, that means it's acting down on the diagonal member. So that's pulling that down with a load of 4,500 pounds. Also, again, if we look back at the previous slide here, we found that the joint here at B is pulling the horizontal member to the left. That was its sense with respect to the horizontal member, which means it's in the opposite direction with that diagonal member. So it is going to the right with a force of 6,860. Now up here at joint A, we had previously found, when we found the reaction forces at the beginning of this frame analysis, that this was 6,860 and that the vertical reaction at A is 7,000. In addition to that, we have this load of 2,500 being applied to the diagonal member. So really, just to double check everything we've done so far is correct, all we need to do is sum the forces in the x direction and make sure that it equals 0, which it should. So if we start here, we've got negative 6,860, and over here we have positive 6,860, and that's it. Those are the only two horizontal forces, so they cancel each other out. They do equal 0, so everything's good there. Now let's sum the forces in the y direction. Starting at the left, working our way to the right, we have positive 7,000. We have negative 2,500. We have negative 4,500. And that's it. Those are the only three forces in the vertical direction. We add them up, and again, everything equals 0. So it looks like this has been done correctly. Everything, when we add up all the forces in the x and y directions, it all cancels out to 0, which indicates that it's probably all correct. And so again, I like to suggest to you to put your answers in a table with a column for x and y, and let's just label all of our joints A, B. We don't really need to do C. C is not a joint. C is just a location on the frame, but there's no joint there. There's no pin. And D. So we really just have A, B, and D. A in the x direction is 6,860. In the y direction, it's 7,000. B in the vertical direction is 4,500. Horizontal, in the horizontal direction, B was, again, 6,860. And at D, in the vertical direction, 1500. In the horizontal direction, 6860. So this is a good way to organize your work and make sure that you have completed all of the unknown forces. And that's it. So again, frame analysis is all about finding the pin reaction forces on the frame members. You have to think about it in that way. How is the pin affecting the frame, not the other way around? We want to find the external reaction forces before we begin if we can, but sometimes we can't, and that's okay. We just move on and start our free body diagram of one frame member, and eventually we'll find all of the missing forces. If we assume the sense is one direction of a force, and by the solution of our equilibrium equation we get a negative answer, that means our assumption about its direction was wrong. And so, and then finally, if we get to the last frame member and we sum all the forces in the x and y directions, everything should cancel out. And in this table, it doesn't really make a whole lot of sense to call any of these forces positive or negative because they're actually working in both directions. For instance, at joint B here, the vertical force of 4,500, it's pulling the horizontal member up, which means it's also pulling the diagonal member down. So it's sort of both up and down, so we don't really need to label it with a positive or negative sign. Okay, I think that does it for frame analysis. I may make some additional videos showing a few more example problems, but this covers all the concepts, so you should be able to get started on the homework now. If you have any questions, post them to the discussion board or ask them when I see you in class.